Picking up where we left off, let's talk about ions. So elements will quite often lose or gain electrons during chemical reactions. When this happens, we no longer call those things atoms. We now refer to them as ions. And if an ion has more electrons than protons, which would mean that it has a net negative charge, we call those things anions. So again, if you have more electrons than protons, that will give you a net negative charge, and we call those anions. If you have fewer electrons than protons, so something came along and stole some of the electrons, then you will have a net positive charge, and we call those things cations. So cations have positive charge, anions have negative charge. The charges on these things are indicated by a little sign and a number in the top right corner of the chemical symbol. So calcium that has lost 2 electrons would be Ca2+. And it is the common convention, I guess you could say, to put the number first. Now, if you just have one, you can just put a single plus sign or a single negative sign. But if you have more than one, so you have 2 or 3 charges, if you have 3 negative, for example, it would be 3 negative there. So it kind of seems backwards. It seems like you should put -3, but from everything that I have seen in most books that I have read, the convention is to put the number first and then the positive or negative sign after it. So if I accidentally say it the other way, just know that it should be written this way. Alright. So when we're trying to determine how many protons, when we're trying to determine what the charge would be on an element, it's a pretty straightforward way of doing that. We're just going to take the number of protons that we have in the element and subtract the number of electrons. And that will give us the charge on the ion. So we have a couple examples here. I'll just look those up real quick in my book. So we have example 4.4 and 4.5. So 4.4 says it wants us to determine the charge on each of these ions. So we have 3 different possibilities here. We have magnesium with 10 electrons. We have sulfur with 18. And we have iron with 23. By the way, this little E with a negative sign, that is a shorthand way of writing electron. So if you see me writing that in, I'm not just going crazy. That is a shorthand way of writing electron. So we have magnesium with 10 electrons, sulfur with 18 electrons, and iron, almost said fluorine, iron with 23 electrons. So if we're going to determine the charge, we're just going to use this equation here. It's the number of protons minus the number of electrons. So I would encourage you to actually try and work this out on your own. Now that I've written down everything that you need there, go ahead and pause the video. It should only take a minute or so, and determine the charge of each of those ions. Alright, I hope you gave that a shot. For the first one there, we have magnesium. Really the only thing that you needed to work out for this, other than doing the simple math, is that to get the number of protons, you have to go to the periodic table. Because remember, the atomic number at the top of the symbol is the number of protons. So magnesium is number 12 on the periodic table, which means that it has 12 protons. So that would be 12 minus 10. Since we have magnesium that has 12, we were told it has 10 electrons, and so that would be plus 2. So we would have magnesium 2 plus as our ion. For the next one there, we have sulfur. Sulfur is element 16, so it would have 16 electrons, and we were told that our ion has 18 electrons, which means that we have negative 2. So that would be sulfur 2 minus is that ion. That is the charge on that ion. And then the last one there is iron. Iron is element 26. So we have 26 minus 23, which gives us plus 3. And so there you go. Iron 3 plus. That is the ion that is created. The next example there, 4.5. Flip back to that real quick. It asks us to determine the number of protons and electrons in calcium 2 plus. So that's what we have, calcium 2 plus. Why don't you pause the video, see if you can figure out how many protons and electrons that element has. Alright, hopefully you found that calcium 2 plus has 20 protons, as it is element number 20. And since it has 20 protons, and we were told that the charge is 2 plus, what that tells us is that we have 2 more protons than electrons. So we have 18 electrons. The most common mistake that's made here is you see 2 plus and you think, oh, I have 2 extra. And so you think I have 2 extra electrons, when in fact you have 2 extra protons in this case. So don't be thinking of the plus as telling you extra. Think about it in terms of the actual charges that are at play here. So a plus 2 means 2 more positive charges than negative ones. So 2 more protons than electrons. Alright. You might have noticed, by the way, that magnesium ended up with a charge of plus 2, and calcium, we said, had a charge of plus 2. And both of those are in the same column together, magnesium and calcium. They both have a charge of plus 2. This is not a coincidence. When elements are forming ions, elements tend to gain or lose electrons to try to get the same number of electrons as a noble gas. If you remember from the last video, the noble gases are very unreactive. They're very, very stable. They don't form compounds. The reason for that is their electron structure, which we'll get to much later in the class, is very, very stable. It's happy in a sense. The atom is happy with the way that its electrons are arranged. And so everything else wants to be that way. Everything else wants to be very stable, like the noble gases. And so these elements in these main groups here are going to gain or lose electrons to try to get the same number of electrons as a noble gas. So everything in the halogens column will try to gain 1 electron to be like whatever the noble gas is that they're next to, which means everything in this column, when it forms an ionic compound, is going to be -1, because it wants to gain that 1 electron and no more. Because as soon as it gains that 1, it's like a noble gas. The next column over needs to gain 2. Oxygen needs 2 more electrons to be like neon, whereas nitrogen needs 3. So everything in this column will tend to be -3. Now once you get to here, it gets a little bit more wonky. Some of these actually will be +4 and some of them will be -4, just depending on what you're looking at. So we're going to kind of ignore this column for now. But once we get over to this column, now we're actually closer to a noble gas by going in the opposite direction. So aluminum, for example, yes, it could gain 5 electrons to be the same as argon, but it's much easier for it to lose 3 and be the same as neon. It's much, much easier to lose 3 than it is to gain 5. So once you get to this point, and this is true for these 2 columns over here as well, it's easier to lose the electrons than to gain them. So the main point of this slide here is just when we're trying to determine what the ionic charge is most likely to be for an element, its location on the periodic table is a very big clue. Now there are a few exceptions that we'll see to this later on, mainly with these guys in here. You might have noticed I didn't say anything about those. We'll talk about those later. But in these main groups here, for our purposes, we are going to assume that they are always going to have these common charges. Everything in this one is going to be -1. Everything in this column is -2, -3, +3, +2, +1. Now my one caveat here is that I will often have students getting confused because they'll hear me talk about this slide and they'll be like, got it. Absolutely. Fluorine is always going to have a -1 charge. Oxygen is always going to have a -2 charge, and so on. My caution is that this is true in ionic compounds. Later on, I believe in the next chapter, we're going to talk about compounds that are not ionic. So there are going to be molecules where this is not true. And these are what we would call covalently bonded compounds. So in an ion, when these things gain and lose electrons, this is absolutely true. Everything here will be -1. Everything here will be -2. But we're going to see molecules later where they're not gaining and losing electrons, they are sharing electrons. And so that'll be a little bit different. They're not going to have charges in that case. So just keep that in mind for now. So if later we're talking about oxygen in a molecule and it's not charged, you don't freak out. If it's going to be charged, if oxygen has an ionic charge, it will be -2. But it's not always going to be charged. So I hope that makes sense. All right. I was going to include this in this same video, but it'll end up being a pretty long video if I do this in here as well. So I think we'll go ahead and cut this video here, and we'll give isotopes its own video. So we'll stop this for now. In the next video, we'll talk about atoms where the number of neutrons is different from one to the next.